Hi everyone, welcome to Unit 3 of DAX 601. Before I begin with the content, I just want to say thank you to those of you who let me know that my previous microphone setup wasn't really effective. I tried using an external microphone because I have rabbits. You're going to probably hear them a bit more now, but I was hoping that it would be able to block out their noise. Because you've let me know that the audio is inconsistent, I'm going to use a different microphone setup, so please let me know if this video is also difficult to hear. All right, now that that's out of the way, in Unit 3, we're going to discuss describing data, tidyverse, and data tidying. So we've already figured out how to read in our data. Now we want to learn how to work with it a bit more in depth. This week, we'll have two videos. The first will go over data description, the tidyverse universe, and data transformation. And then in the second, we'll go over data tidying and the active duty marital example. So first, describing data. It's really important for you to have a sense of what it is that your data set contains. And we can start with these definitions. So these are found in Chapter 1 of the R for Data Science textbook. The first is a variable. And a variable is a quantity, quality, or property that you can measure. I like to think of this as the columns in your data set. So each column describes a variable. It could be age, or height, or year in school. The value is the state of a variable when you measure it, and that's a particular cell. So for example, it could be freshman in college or 5'0" for height. It's that individual measurement. And then an observation is a set of measurements that are made under similar conditions. And I like to think of this as a row. And the idea is that the row represents attributes about the same thing. In this class, I'm going to ask you to identify the unit of observation, and that's what I mean. Is the unit of observation maybe an individual who's responded to a survey? So all of the columns represent their responses. Maybe it's a pet or a country, something like that. But this is what it's important for you to just understand as you go through the data. And we're going to go through the penguins data set, which you encountered in Challenge 1 as an example. So let's switch over to our R Studio. Of course, we have all of our libraries at the beginning. So we're going to pull in Tidyverse, the Palmer Penguins package, NYC flights again, and then read Excel and here, of course. And what we're going to do with penguins is first look up the information that we have here in the help panel. And now you might find this information in other places. So for example, let's say you're pulling a data set from Kaggle. Go through all of the information that you can find in that data link. In the data sets that we provide here, we're either going to tell you what you need to know, or we'll provide you with a document that you can search through to find this information. But what I see immediately here is that we have a list of the different columns or variables that this data set contains. And let's actually start pulling in the data. So I pull in the penguins data from the library using this command, and then when I type head, the data is now in my global environment. And so we can see head, the first few columns and rows here, and we can also see the data more in depth here. Now, the first thing we're always going to do is check out the dimensions. We can do that in a few ways. One is that you look up here, you see this in our global environment, that there's 344 observations of 8 variables. And we can also use the dim function. So that will pop out the same thing here. It always pops out rows and then columns. And the next thing is to figure out what the columns mean. Now this is important because sometimes you'll be going through your data and you think, I have to create a new column because you haven't read through the provided columns in depth. And I'm actually talking from my own experience here. In the past semester, I had a class where I was so confused about how I was supposed to complete a particular task. And then I realized, when I actually looked at the data documentation, there was a column that gave me the exact value that I wanted to know. So one, it helps you if you just do the work to go through these things ahead of time, so you have a sense of what's in your data. And it also helps you determine what is not in your data. So for example, the penguin dataset tells us about species. So it lists out the species, it lists out the particular islands, it lists out things like bill length and depth and flipper length and all of these things. But it doesn't tell us things about mating behavior, for example, or it doesn't tell us things about penguins that aren't of these three types. So it's important as you're exploring a data set to try to get a sense of what it does tell and what it doesn't tell, because no data set can tell us everything. And then our third step is to determine the unit of observation. And so let's see. We know from the description here that it includes measurements for penguin species and the island and so on. And when we look here, it looks like the unit of observation is an individual penguin. So each row tells us the species, the island, and then individual measurements and so on. And that's what I want you to think through every time you encounter a new data set. Let's go back to our slides. Tidyverse. So I've alluded to Tidyverse previously. Tidyverse is the universe of packages that we're going to primarily use in this class. And Tidyverse goes along really, really nicely with our textbook. So the Tidyverse is this collection of packages. We've already encountered readr. We're going to encounter tidyr and dplyr today. But this is everything to do with the textbook that we follow. And when you import Tidyverse, so when you call library Tidyverse, you get access to all of these packages. And I bring up Tidyverse here because Tidyverse tells us about tidy data. And the principle of tidy data is that each variable is a column and that each column is only one variable. The next principle is that each observation is a row and that each row is one observation, so observations aren't scattered across different rows. And then finally, each value is a cell, and each cell only contains a single value. The idea is that we don't want to have, for example, maybe multiple values in this population column. And we don't want a single observation. So in the penguins data set, we don't want a single observation to be scattered across different different rows. And we're going to get into how to create this later on in the videos. But that's what the Tidyverse helps us with. All of these packages are designed to help us with exploratory data analysis and to make our data tidy. Let's talk about data transformation. And we're going to have 2 weeks devoted specifically to more nuanced aspects of data transformation, but we're going to get started here. The package that we use for data transformation is dplyr. And so as you can see from the documentation here, it's a grammar of data manipulation, which helps you manipulate the data to be in formats that you want it to be. And we're going to go through each of these functions. And when we think about dplyr functions and functions overall, here's how I want you to read them. So the first argument that you're going to add to whatever the function it is always the data frame. So is it the penguins data frame or baby names or whatever the data frame is? And then the subsequent arguments typically describe what columns to operate on. So let's say we want to use the flipper length column in penguins. That's going to be our second argument. And typically we don't have to use quotes for these. So you don't have to put column names in quotes unless they contain a space or one of the things that R doesn't recognize. So here we have data frame and a column. And then the output is always going to be a new data frame. Something that you've encountered in the tutorials and that you're going to continue to encounter here is the pipe. So we see here flights and then this thing, which is just the vertical line and greater than. I like to read the pipe as the then. Literally, I read it as, okay, flights then, and then I think of these functions as verbs. So flights, then I want to filter, then I want to mutate, and so on. And the purpose of the pipe is to allow you to combine multiple functions. So rather than having to do flights then filter, and then flights then mutate, flights then select, instead we open up flights and we do all of these things to it. And then you always want to create a new line after this. If you end with a pipe, R is going to throw an error at you and say that it can't complete the task. So the pipe is really, really commonly used in this course. When it comes to rows in our data frame, there's a few ways that we can adjust them. The first verb or dplyr function is filter. And filter can change which rows are present in our data set without changing their order. So for filter, we're going to use our logical operators, which you got some experience with in challenge 1. And we also must use equals equals equivalent rather than just that single equals to. Arrange can change the order of the rows without changing which are present. So filter, you select which rows you want. Arrange, you change the order that the rows are in. And then distinct can find all of the unique rows in a data set. For our columns, we can use these 4 functions. The first is mutate. Mutate is really helpful because it helps you create new columns that are derived from existing columns. So in penguins, for example, let's say that the flippers are measured in millimeters, and I don't actually remember the unit, but this is just an example. Well, let's say you want to convert it to inches. You could use mutate to take the existing column, make a calculation, and now have a new column called inches. The next is select. That is going to change which columns are present, so you can choose which columns you want to keep. Rename is helpful. It helps you change column names. So let's say the column name isn't descriptive or it's just super long. You can use that to change it. And then the way that this works is rename. You put the new name equals old name, and that will change the column name. And then finally, relocate will help you change positions of the columns. Let's say you want to put year, month, and day, for example, all together, or you want to have one column in the very beginning. Relocate will help you do that. Our next group is grouping. So grouping is really, really helpful when we want to organize the data in a particular way. Group by breaks down a column into its groups. So you could think of month, gender, education level, and etc. And it's going to report values based on those groups. Summarize, which you've already encountered, creates a new data frame, and it helps when you use descriptive column names. So I always advocate that every time you use summarize, that those column names are very, very descriptive. So here the output column will be mean, and then you take the mean of the column, and so on. And then finally, slice allows you to extract specific rows from each group. So let's move again back to our R script to make this a bit more clear. Give me a second to pull it up. Great. So moving to data transformation. Again, this section is going to use functionality from dplyr. Your first data set is flights, and that's referenced in chapter 3, and we've also used it in previous videos. So here, we pull in the data, and just, again, if we want to look up the information about flights, we can do so here. On your own, I encourage you to figure out the following things. Go through using this description right here in the help panel, figure out the dimensions of the data, what the columns mean, as well as the unit of observation. And I'm going to go ahead, just look at flights here. There we go. Now it's in our environment. So let's play with transformation based on rows. Our first function or verb is filter. So let's say that what we want to do is we want to figure out what flights were delayed for more than 1 hour. What I do is I open up flights. I use our pipe to say then, so flights, and then we're going to filter every instance of the departure delay column that's greater than 60. So we specify the column, and then we give the condition. And here we go. We can see that right here. Departure delay, all of these are greater than 60 minutes. Let's say we want to figure out what flights departed on a specific day. I'm going to use July 18th because that is my birthday, but we see here that our columns, we don't have a singular, July 18th or a month and date combo. So what we're going to do is we're going to filter month to be equivalent to 7 and day to be equivalent to 18, those two columns. And here we go. All of these are flights that departed on my birthday across the year 2013. And let's say that I want to save this. That, okay, it's popping up in the console here, but it's not being saved. I can very easily do that by creating a new name and then assigning my flights and then like the transformed data to this. So flights Larry birthday is my descriptive name. I'm opening up flights, the original data. I'm using pipe to indicate then, and then I'm filtering based on the month and day values that I want. So here, flights Larry. Now we can see that there were 1,003 flights that departed from New York City on my birthday in 2013. Well, let's say we don't care about my birthday, but we just want all of the flights from summer months. We can do this. So again, I have a descriptive name, we're filtering, and this time I'm going to use the in operator across months 7, 8, and 9, or July, or June, yes, July, August, and September. So here we go. Great. Flights, summer, here. I can also arrange the data in ascending or descending order, and this is really, really helpful. There will be an example later on that shows you why, but essentially you want to figure out what the biggest or the smallest values are. This is how we can do that. So we're going to arrange the Larry birthday flights in descending order. And you notice here I have two functions. So we have descending on departure delay, and then we want to arrange based on that descending value. And now we see here, departure delay, there we go. Or excuse me, right here is the departure delay. And so the longest departure delay on my birthday back in 2013 was 396 minutes, which is over 6 hours. Uncomfortable. Okay, let's say I want to know how many different carriers there are in the data. I can do this in a single line, so I can use the ndistinct function. And again, if you want to know more about any of these functions, you can always just type in question mark and look them up. So ndistinct gives us the number of distinct values in a particular column. And here what I'm doing, rather than using the pipe operator, is I'm saying flights, money sign, carrier. So that's pulling just that individual column. And I can see that there's 16 distinctive carriers in the flights data. I can also use summarize. So here, we're opening flights, we're using our summarize function, which always generates a new data frame, and we're going to call the column unique carriers and use that ndistinct function. And we see the same thing, unique carriers and 16. I can also use summarize to check distinct values across multiple columns, and this comes in really, really handy. So here I use the across function, and then I list, using C, combine the different columns that I want to run ndistinct on. So here, great. Now we see the distinct carriers. There's 3 distinct origin carriers, which makes sense because this is just flights that departed from New York City, and there's 105 distinct destination carriers. Or excuse me, airports. Okay. We can also transform based on our columns, and the big one for that is mutate. So for example, when I checked how many hours 396 minutes was for the above example, I could have pulled out my calculator. But R itself is a calculator, and I can instead use mutate to create an hours column. So here we're going to create a new data frame called flights departure delay hour. Just again, I like descriptive names. We open up flights, and then we're going to use mutate to create a new column. So my new column is departure delay by hour, and that is equivalent to the existing departure delay column divided by 60, because this departure delay column is originally in minutes. So it's really easy. You can perform math or other sort of transformations on an existing column to create a new one exactly like this. And then what I'm going to do is I'm going to move this new column to be directly after departure delay, because to me it just makes the most sense to have them next to each other. So here we go, flights departure delay. Let's open that up. Now departure delay hour is right after it. So if the departure delay was only 2 minutes, now we see that it's 0.0 blah, blah, blah hours. And then I can also arrange by hour. So flights departure delay hour, I'm going to arrange in descending order by the new column we created. And what we see is that the longest delay in 2013 was almost 22 hours. And so this makes it so that we can easily figure out max and mins and other trends in our data. We also are going to encounter a data set with way more columns or variables than we ever want to work with. And so it can be a good idea to select just what you want to use for your analysis. To do this, we're going to use the select function. Here for flights, let's say I just want to select the date or the time variables. So I'm going to select year, month, and day. And here we go. My new flights data set just has year, month, and day. And again, if I want to save it, I have to adjust that first line. Otherwise, this is just popped up in the console. Let's say I want to keep all of the columns except those with the date information. So for whatever reason, I don't want the date. What I can do is use, again, this not operator. So I want to select everything that is not the year through day column. And this says exactly that. I want to go from year through day, all of those columns in between. And we'll see flights no date. Over here, there's now no date columns in here. Well, I didn't exclude time hour, but you see the point. Let's say I don't want any of the columns to have the word dep in it. I can do the exact same thing, select everything that does not contain dep. And we're going to put that in quotation marks because we want to exclude all of the columns that contain that string value in them. So flights no dep. Here we go. None of those dep delay columns are in here now. Finally, rename. So rename is going to rename a column to be something more useful. So again, this is really helpful when you're going through data and those names don't make sense, or they're going to be if it's associated with, let's say, an experiment or a survey, the names might just be a lot of numbers that instead of age, it might be like Q1, and you want it to be descriptive for your work. So let's say for this example, we're going to rename distance to distance in miles. And remember, rename functions by new name here equals old name. And so I want to include the miles. And we'll do that. Flights rename. We look here. Distance in miles. Relocate again allows you to move those variables around. So flights rename relocate. Distance in miles is right up front. Now, in your regular data analysis, you're not going to be creating all of these individual data frames. I'm doing this just so that you can see the difference between them easily. Finally, let's go through group by. Group by and summarize are both really, really useful. So for here, what we're going to do is we're going to open up that flight's departure delay hour data set that I created, where we created the hour delay column. I'm going to group by the origin airport. So what it does is it collapses everything so that way it represents each origin airport as a unit in the rows. And then I'm going to summarize across all the different entries in those groups. So here, summarize the average hour delay is going to be the mean of the departure delay hour column. We're going to exclude the NA values from our calculation. And then we're going to create a count column here. So N just counts all of the observations in the group. And let's see here. Now we can see that across all of the rows in our data set, the average delay for the EWR data set is 0.252 hours. For JFK is 0.202, and so on. And then that count column lets us know the number of departures from each. So groups really helpful when you have different categories. So we have the different airport types, or maybe we have the different years in school. What we can do is calculate statistics, so mean or max or whatever, across those groups. We can also group by multiple columns. So let's say we want to group by both origin and destination. Here we can do that here. And let's say we want to figure out what origin and destination combo has the highest hour delay average. What we can do, again, we're going to use that departure delay data set that we created. We're going to group by both the origin and the destination. we're going to summarize the mean delay, and then we're going to arrange in order, in descending order. What we can see here is that we keep the group by columns. So if you want a column to show up in the summarize data frame, you have to include it in the group by. We see for all the flights that go from EWR to TYS, and I apologize, I don't know most of these airport names, the mean delay is 0.697 hours, and so on. Slice is going to allow you to extract specific rows from each group. So slice can be helpful if you want to figure out the top 1 or the top 10. What we do here, very similar. Flights, we're going to group by origin. Then we're going to slice max of 1. We just want to keep the top departure delay amount, and then we're going to relocate that. We're going to relocate the origin column to make it easier to see. That we see, great, okay, from EWR, again, we grouped by the origin, the highest departure delay in hours was 18.8 hours, which is wild. Then JFK, 21.7, and LGA is 15.2. So that's it for the basics of data transformation and data description. In our next video, we'll go over data tidying.